Well, first of all, good morning, ladies and gentlemen, and thank you so much for having me here. It's my first time in Japan, and I'm very excited. And today, we're going to talk about an abusive relationship with AngularJS. Who here knows already what AngularJS is and what it does? Some people do. That's great. Let me first introduce myself. My name is Mario. I am a researcher and postdoctorate at the Ruhr University in Bochum. I lead a penetration testing firm that is located in Berlin, and we essentially do penetration tests, security trainings, and security consulting. I wrote some books, wrote some papers, maintained some security-related projects. Some of them you may know, like the HTML5 security cheat sheet, DOM Purify, and others. And I do tweet, mostly nonsense. But if you want to follow that, you're most certainly welcome. If you do have any questions about the talk material, feel free to send me an email. The email address is there. You can find it online. I will reply as quickly as possible. Now, to get to the actual talk topic, today we would like to talk about AngularJS. And we want to talk about how AngularJS relates to web security, how it changes web security, and what new kinds of attacks we might be able to carry out against websites that are using AngularJS. I do think that AngularJS is a framework that has a strange attitude. And it kind of compares to the attitude of a toddler in a tiara, because some things AngularJS does are, in my opinion, very immature and very hectic and have broken things unnecessarily. And we want to see these, and we want to learn why that is the case and how we, as penetration testers and attackers, can actually abuse that. So first of all, what is AngularJS? AngularJS is a very popular JavaScript model view controller framework. So it does a lot of logic that was formerly done on the server in the browser, in the client. Actually, the developers are calling it model view whatever because it's so flexible that you can do whatever and not necessarily just a controller. It calls itself a superheroic framework because it believes that it has superheroic strength. And we want to see if that is really true. Interestingly, it is maintained and recommended by Google. So if you want to, for example, create a Google Chrome packaged app, a Chrome extension, then most of the tutorials you will find will recommend AngularJS to be used as the JavaScript framework. AngularJS also has a polarizing philosophy because essentially it throws away all the knowledge that you might have before about how to write a web application. And it says, if you want to write a web application, throw all that away that you know and do it in a different way, in our way, in the framework way. We're going to talk about this in a second. AngularJS has an ever-growing user base. More and more developers are using it. More and more websites are using it. You will notice that some of the areas on the slides are orange. Once you have access to the slides, you can click those areas, and then you will be directed directly to the source of what I'm claiming here. It has a very large range of adoption, so you can see that there is a growing graph of websites, like a growing number of websites that are using AngularJS. More and more people are actually adopting to it. And if you have a look at the GitHub repository of this framework, you will see that there is a lot of traffic, many pull requests, many tickets, tens of thousands of commits. So it's very, very popular. It's not the very first time that I've been talking about AngularJS. I talked about it before when covering the topic JS MVC OMFG, which kind of translates to JavaScript Model View Controller, or my friend George. And we have been spotting security issues in AngularJS earlier. But now this is an exclusive talk only covering AngularJS, and I think it's necessary. And I think that the issues that we spotted before were interesting because we decided as a team that those are security issues. But the AngularJS developer team said, no, this is no security issue, no CVE, no announcement, nothing. But we will fix it. So they fixed it. And it led to a strange discussion that is linked here, and you can have a look as soon as you have access to the slides, because we had a security discussion with the developers of AngularJS, and it was not always a good discussion. You will see what I mean when you read the discussion. So is it a personal thing that I'm standing here and talking about AngularJS? No, a little bit. Maybe. But all in all, no. The reasons are different. Well, one of the reasons is that AngularJS has a very strong attitude. And it indeed calls itself the superheroic JavaScript framework. Those are strong words. And strong words need strong checks. So there is a lot of self-love in this framework. And as mentioned, it changes completely the way how web applications and websites work. It also changes completely the way how we penetration test websites. AngularJS breaks the API that it uses and that it offers very often and makes upgrades literally all the time. So someone who is using an old version of AngularJS on their website will not necessarily be able to just quickly install the newest ones because many breaking changes happen, which is not always good. AngularJS also assumes that it's smarter than HTML and adds new attributes, new tags, new events, and new functionality to HTML. We call this markup sugar. And in addition to that, once the version 2.0 is out, again, everything will break and everything will change. Here you can see a screenshot of the documentation of the changelog of AngularJS. You will notice that I'm searching for the term breaking, and I'm finding it once here, and 92 times again on this page. So on this single page that is the changelog, they have 92 breaking changes. That is a lot. So is it really the honey boo boo of model view controllers? Let's find out, because we want to attack it, right? Maybe not. Maybe it is not the honey boo boo of JavaScript frameworks, because they do have high security standards over at AngularJS. And the security level that an application can have, if all the rules are being followed by developers, are great, are really high standard. Both developers and the maintainers have high security standards. But the problem is, it's a complex framework and it runs in the browser. And if you run something complex in the browser, you have to know the browser really, really well. Do they? We'll see about that. I often call it the web security paradox of layers, because web security is often that complicated because everything is a layer and contains sublayers, like the network layer, the database layer, the application layer. The browser itself is a layer and contains multiple layers, and one of them will become AngularJS, interacting with all the other layers, which makes it even more complex. Here is a copy and paste of what the Angular team says about security. They say it's better to design your application in such a way that users cannot change, and so on and so on. And they say clearly that it's not okay anymore to reflect content on the server, to build content on the server, but to have the server return static JSON data and have the browser and the JavaScript framework do all the jobs. Because then you don't have classic cross-site scripting anymore, and that is even true. But maybe there is new attacks, and we want to find out about these. So now the question is, if we want to attack a complex and ever-changing JavaScript framework, how do we do it? And how do we do it in a methodologically correct way that makes sense and that is systematic? I decided to cluster the attacks in 4 areas. The first area would be attack 1, attacking AngularJS sandbox. We're going to talk about this very soon. The second would be attacking the sanitizer. AngularJS has an HTML sanitizer that claims to be able to take unsanitized, potentially dangerous HTML and turn it into clean HTML that you can use without risk for XSS. Third of all, we are going to attack the CSP mode, content security policy. AngularJS is capable of working together with CSP, which is quite unique in the world of JavaScript frameworks. And last but not least, we decided to play dirty, and we attacked the code base themselves. So we attacked the developers, and we did something to AngularJS that wasn't very nice, but proved an important point. That would be A4. Let's talk about A1, the sandbox. The AngularJS sandbox is a mechanism that allows to safely use expressions on your website that follow a certain kind of microsyntax and allow a developer to express certain things in a template. Simple logic, simple variable assignments and calls. Now the question is this safe? And how do these expressions look like? And what happens if an attacker can actually inject into one of these expressions? The developers of AngularJS say the sandbox exists not for security purposes, but the core purpose is to isolate everything from the original DOM, because they don't want developers to interact with the DOM. They want developers to interact with their API, but not the original DOM. This should be locked away. But they clearly say it's not a security tool. They still call it sandbox. And given the practical experience that we had from the last months and years, developers actually do use this as a security feature and do put user content in there. And then we might have a sandbox bypass, and as a result, a cross-site scripting. The first AngularJS sandbox bypasses were trivial. The only thing that we had to do was basically create an expression with the double curlies, and then we would say constructor alert 1. So we would jump from the scope to its constructor object, receive function, then we have an eval, and then we just execute whatever we want. So that is very trivial and was fixed quickly. This worked in old versions of AngularJS, 1.0, 1.1, and it stopped working in 1.2.0. But interestingly, many pages still use old versions of AngularJS because of the breaking API and because of it being hard to update AngularJS once you have a complex application already. So this would be the full bypass of one of the older versions. Trivial. You import AngularJS. You declare ng app. Make sure that the container you inject into is a real AngularJS app. And then you say constructor alert 1, and that's it. That was the first bypass. But that was simple. And they fixed it. And they implemented interesting fixes. AngularJS has a parser, and this parser is capable of parsing expressions and turning them into code. And all they had to do is modify the parser and make sure that the parser doesn't accidentally hit something dangerous and execute it. And the patches that they made are actually quite smart. They are prohibiting access to function. They are prohibiting access to window. They are prohibiting access to DOM elements, to events, to location, to pretty much everything that can execute JavaScript from a string. But people were getting interested into that and had a closer look at how that sandbox actually worked. And some of the bypasses I'm going to show because they are very creative. The finders here are Jan Horn, Matthias Karlsson, and Gabor Molnar, and one of those bypasses including myself. And we needed to find ways of still being able to execute arbitrary code from within an expression despite all the protection mechanisms. Now, how would that look? Here's a bypass created by Jan Horn. And you would see it's very simple. You just take a string, you call sub, and then you say call of that sub method from the string. Then you fetch the constructor as a string. Then you call get on property descriptor. You throw the underscore proto in there. You call its value. You return this whole thing. You get a string and done. That's trivial. Well, maybe not. But you can see that bypassing the sandbox gets harder. Of course, they fixed that. Then I realized that there was a gap in the history of bypasses because we want to make sure that for every version, we have at least one bypass. So I had a look what the problem was, and I realized that in version 1.2.0, you have to do something else because they check for more things. In the former bypass here, you could see Jan using proto. In 1.2.0, proto all of a sudden is forbidden. And we cannot use it anymore. Instead of using proto, we can now use get prototype off, which pretty much does the same thing. So this was another bypass, otherwise similar. Then there was a bypass created by Matthias Carlsson. He was pretty smart. He said, let's take toString of the scope object, its constructor, its prototype, its toString, and override it with toString, constructor, prototype, and call. So toString is being turned into a call, only that the framework doesn't notice. Then he creates an array with two elements, a harmless element and a malicious element. Then he sorts that array, and afterwards, he just passes the malicious constructor that he just overrode. You would get a function call, you would get an eval, sandbox bypassed. Gabor's bypass is even more complex. I suggest we're not going to go through this thing right now because it's going to consume too much time. But if you are interested in how it works in the detail, please approach me after the talk. But you can see it's getting more complex. There is another possibility to bypass it by using event handlers. You can say, we have an event handler here, ngFocus, and then you access the event object. You access view, which is window. You access location. You access location replace. You throw in a JavaScript URI, and then you do it. Much more simple, but not as generic. And last but not least, there's a new bypass that is also working against 1.3.2, and this is really extreme. It looks like this. As mentioned, maybe I should explain it piece by piece after the presentation, because otherwise we would be sitting here 1 hour. However, this is the current state, seemingly. And after 1.2.3, the sandbox was considered secure. Access to pretty much everything has been restricted. No window, no function, no object, no call, no apply, no document, no DOM nodes, nothing. Everything was blocked. But was that really the end of the road? Is it really safe now? No, it's not. This is a bypass that is working against almost the newest version, 1.4.5. And this time it makes use of a trick where you don't exactly directly access proto, but indirectly with the string being an element of an array, being an element of an array. And then you call eval, which is being provided by AngularJS as a secure alternative to real eval. That was fixed. And meanwhile, the bypasses have reached a level that seemingly cannot be fixed anymore, where the maintainers seem to have given up. One of them I have here that was found by Gareth Hayes. And you can see it's getting even more simple because he directly attacks the eval and not the sandbox anymore, which is very interesting. And there is, last but not least, one more bypass that, however, requires user interaction, but I think it's fun. And it looks like this. It's a sandbox bypass that requires you to use copy and paste, because it basically abuses the expression parser inside AngularJS to fill your clipboard with malicious data. And the next time you paste, you have an alert and a JavaScript execution. So you can see building a JavaScript sandbox is hard. Maintaining a sandbox is even harder. But making sure that the sandbox doesn't break too many things and still is secure is close to impossible. There will always be bypasses. It's just a matter of time. Whenever you run into a pen test where you have to penetration test a website that is using AngularJS, always have a look at the bypasses, always try to play with them. Don't use classic XSS vectors. Use those, because they will work. The classic ones won't. Let's talk about the next attack, A2. And let's talk about the sanitizer. As mentioned, AngularJS offers to sanitize potentially dangerous HTML. And for that, it features a component that is called $sanitize. You give it a string that is user-controlled And after it's done with that string, done sanitizing, that string is supposed to be clean and safe to use. Does that really work? Let's have a look. The old sanitizer is being used, or was being used, up until a few weeks ago. And it relied on a core feature on an HTML parser that was written by John Rasek in 2008. So this should give you something to think, like such an old part, like such an old piece of software in a security component, can that go well? Of course it cannot. It is very strict, and it doesn't allow too many things. So you can use links, bold elements, paragraphs, but that's it. But it can still be bypassed. This is the way how to do it. You use an SVG because they are whitelisted. And you use a use element inside the SVG because it's whitelisted. And all you need is some JSON response or some image or some PDF or anything where you can control the contents. And then you have an XSS and you have a full-blown bypass. We see these bypasses a lot, and they work and almost universally. Because Chrome, for example, does not check the MIME type. And it doesn't matter what you fetch with SVG use. It will still execute. Then they built a new sanitizer, one that is not that broken. And now they are using document implementation, a DOM feature that is supposed to be safe. We also use it with DOM Purify, so I hope it's safe. It's still very strict, but they made it even more strict by prohibiting SVG, because they realized SVG is hard to tame. But it's, of course, bypassable. The trick here is to use Chrome, because Chrome has a bug. And if you have a URL in Chrome like this, using a Unicode whitespace in front of the protocol handler, and then you feed that to the sanitizer will say, that is safe, because it's not really a JavaScript URI. Then you take the resulting HTML, and you put it into the page with inner HTML. This is what you normally do. Then Chrome will internally mutate the whitespace, strip it, remove it, and thereby activate the JavaScript URI, and you have a bypass. This works for this, and all those characters. So whenever you run into an application that uses the sanitizer, try to play with these kinds of URLs, because you're very likely to bypass it. So again, we can see creating a sanitizer is easy. Creating a sanitizer that actually works and knows about the browser's shortcomings is much harder. And that is, again, the part that is missing. They created something, but they didn't go into detail. Let's talk about A3, attacking the CSP mode. And now it starts to get funny. As mentioned, AngularJS is capable of being compatible with CSP, Content Security Policy. Who here knows CSP? CSP is amazing because CSP is a good technique to actually stop cross-site scripting from happening. Because CSP restricts the scripts that the browser is allowed to execute. That means no more external resources, except the ones that are whitelisted. No more eval, no more location assignment, no more DOM XSS, no more event handlers. All these are gone. CSP blocks all of them. So most of the frameworks that exist don't work with CSP because they use the function constructor to evaluate template expressions. AngularJS, however, does work with CSP. It has a special mode. So the only framework that you can use just so on a website that is utilizing CSP is AngularJS, making it even more popular. But we want to bypass that. And we want to abuse AngularJS to bypass CSP. Is that possible? It was, quite easily. In a website that is not protected by CSP, where you have an injection, you can easily do this. You just inject the onClick, alert1, and done. Cross-site scripting. Trivial. But if CSP is existing, you can't do that because it's blocked. Not if AngularJS is there. Because AngularJS uses markup sugar, as mentioned before. And they bring their own event handlers. For example, ng-click. And inside this event handler, you have access to an object that is called $event. $event is the actual DOM event. And every DOM event exposes window via the property view. So this is window. That holy and very important property in the DOM that you always want access to. It's right here. So all you have to do is say window alert1 and done. You have a full-blown XSS despite CSP, thanks to AngularJS. Of course, they fixed that. This is what you could do back then in older versions. You could inject ng-click, ng::click, x-ng-click, data-ng-click, or if you wanted to, underscore, minus, underscore, minus, underscore, and so on, because they normalize the attributes before they parse them. So you can feed the parser nonsense, and it makes something reasonable out of it. So when you run into a whitelist or a blacklist, try to play with these. They might give you a cross-site scripting. But as mentioned, they fixed that, of course. Well, interestingly, there is two bypasses. One that is theoretical, we're going to see this now, and one that is universal in case one condition is given, and that condition is common. The theoretical bypass uses ECMAScript 6, the new version of JavaScript. And it makes use of the reflect API. Because combining a flaw on Chrome and blob URIs and the reflect API, you can inject code into an expression that will end up to become actual arbitrary JavaScript execution. Now, how does that work? It essentially works like this. Since this is a bit complicated to read, I would like to explain it in more detail on the next slide. We have to read from bottom to top to understand what is going on. First, we build the blob. But we don't build a regular blob. To build a blob in JavaScript, we need the new operator. But in AngularJS, we can't use the new operator. It oppresses that. So we bypass that restriction by using ECMAScript 6 and the new reflect API. Because with that, we can omit the new operator and can do this in a functional way by calling reflect construct. This is equivalent to the new operator. Then we have a blob. We fill that blob with HTML. We fill that HTML with JavaScript. We create a blob URL. And then we throw that blob URL into location replace. And that is allowed despite CSP. And interestingly, for blob URLs, Chrome forgets about CSP, and we have a full-blown code execution, despite CSP being in place in the first time. Sadly, this is theoretical because Chrome does not yet support reflect. Firefox does, and Microsoft Edge does. Chrome not yet. Let's see. Maybe tomorrow this works. Maybe in 1 week. Maybe in 1 year. We don't know. But we don't want to see theoretical bypasses. We want to see real bypasses. So the real bypass is actually quite funny because it's not a real bypass. The problem is something else. And the problem is something that cannot be fixed easily. Because imagine a page using AngularJS, newest version. No bypasses, no CSP bypasses. And it's fetching AngularJS from a content delivery network. And you have an injection on that page. Well, the first thing that comes to mind is I can maybe just include an older version of AngularJS and overwrite the existing one and bring the old bugs back, the old bypasses. That might work. But then you might think, this cannot work because it's a race condition. We have to be slower than the new AngularJS. And the old AngularJS is smaller than the new AngularJS. So the older one always loads faster than the newer one. So the newer one comes later and will get control over the DOM because it executes last. But the fun thing is there is no race condition because the developers decided to implement a collision check. That means that old AngularJS versions might collide. You can fetch 2 of them or 3 loading at the same time on the same page. But newer versions have a collision check, and when they find a different version, they say, ooh, I have to get out, and they won't load. So that collision check is winning the race for us always and at all times, no matter how new the AngularJS version is. Because the newer one, whenever it loads, will find out, hey, there is one already. I will stop now. I will not load. And then the old version wins. And you have all the bypasses back. That looks like this. Here you see strong CSP headers. Here you see the latest version of AngularJS being fetched. That is there in the first place on the injected page. And here's our injection. We inject here. We close the attribute. We fetch an old version of AngularJS. We assign the event handler. We say event view alert 1, and that's it. Just fetch an older version, and you will always have a universal bypass. So the mistake that they made is that they implemented a collision check, which is good. But they did it too late, which is not so good. So this bypass is going to stay and is going to be hard to be fixed, if at all. But now for the real fun part. So we don't only want to attack AngularJS code and sandboxes and the CSP mode, but we want to see if we can really be evil and attack the framework itself and the developers. And there was a coordinated plan that I developed with Google and the security team. And we wanted to find out if we can smuggle a bug into the AngularJS codebase and see if the developers notice. Let's see how that went. I mentioned already that AngularJS has a lot of traction, a lot of commits, a lot of pull requests, a lot of tickets, a lot of users who contribute. So we wanted to abuse that and the fact that it's so popular to sneak in our payload. The only thing that we needed was the stars to be in the right constellation for an attack. And with a framework that big and that complex, this is very likely and very probable. What we needed would be a subtle bug, a small bug that no one really noticed, but that gave us the possibility to sneak in an attack instead. And this attack would have to bypass the security audits, QA, and the scrutiny of the users and developers. Sounds hard, but it's possible. So we were lucky and we found this kind of bug after a long time. And it looks like this. As mentioned, AngularJS has a sanitizer. And we have already seen how to bypass the sanitizer. But those bypasses were all conditional. And we wanted to have something universal. I analyzed the sanitizer closely and realized that it's using a whitelist for attributes. And in this whitelist for attributes, they have 2 attributes that are very interesting. Attribute name and attribute type. Those are SVG attributes. And they allow us to cause cross-site scripting. How? We will see in a second. Now, those 2 attributes are already in there inside that whitelist. So technically, they created their own bypass. But they didn't. They had a bug. Because when sanitizing HTML, they lowercased all attributes. But they forgot that lowercasing in HTML is okay. But lowercasing an SVG is not, because SVG has camel-cased attributes. So you can't just lowercase. If you do so, you ruin the sanitizer because it will not match, even if it's valid. So we decided to file a bug and tell them, you have a bug there, could you please fix it? And we kind of wrote some cases and made it tasty for them. And we were hoping that they won't realize what our actual plan was. So we filed a bug, and we knew if that bug was being fixed, we would get a cross-site scripting for free as a consequence from this fix. And it took 2 months. It was actually close to January 2015 when they saw the bug ticket, and they decided to fix it. And the evil part of me was saying, like, yes. So they fixed that bug and created cross-site scripting. The cross-site scripting would look like this. You take an SVG element, you take an anchor, you have a harmless attribute in this anchor. You say xlink href equals question mark. Completely harmless, doesn't do anything. Then you put something inside this anchor to display it, like a huge circle. This one here. And then after that circle, you put an animate element. With an animate element, you can animate declaratively the parent element of the animate element. And you can pick the attributes that you want to change. But the sanitizer realizes if you want to do something evil. And the sanitizer realizes if you animate a link to a JavaScript URL. So that wouldn't work. But there is a small bypass. And the small bypass is using invalid XML. Because we're having a harmless value here, question mark. And we want to animate that harmless value to a different harmless value, the ampersand. But this in XML, and SVG is XML, is an invalid entity. So the browser will try to animate it to that invalid entity, will then realize, oh, I can't do that. And then it will forget what to get back to. And instead of using the old attribute, it will fall back to the from attribute. And thereby create a JavaScript URI that is active, and you have a cross-site scripting. So we abused 3 things. The browser, the weird intersections between HTML and XML, and the fact that the sanitizer doesn't realize this multi-step injection that is giving us the possibility to animate a link to something harmless but invalid, and then have the browser change it for us to something malicious. And that worked. Needless to say, we, of course, reported that issue to Google Security and told them that we just tricked the AngularJS team and that we tricked them into doing a commit that is giving us a cross-site scripting, and that we knew about this all the time and were kind of playing with them. They informed the AngularJS team, and the team was angry. And they didn't like it. And they were so angry that they didn't want to fix it. So nothing happened for weeks. We did this against a beta version, and the second beta came, and the third beta came. I was like getting nervous, and the 5th beta came, and the release candidate came, and I contacted Google again and said, you have to urge them to fix this right now because you're very close to a release. And then you really have a problem. So finally, they actually did fix the bug, but it was last minute. The consequence of that is that the AngularJS team doesn't really like me anymore. But I think that is okay. Another good consequence is that they now have extra security in their sanitizer. So they added a comment that says, nobody ever just touch it, or else. Because someone was here and did evil already, and we don't want to have this happen twice. So now they're more careful. But the funniest thing was in the end, because the AngularJS team really didn't like us for that. But the funniest thing was that we even got bug bounty. So we saw a bug. We realized that the fix would be a security problem. We filed that bug. We convinced them to fix it. We had them create an XSS for us. Then we told Google, and Google told them to fix that thing. They were angry, and in the end, we even got bug bounty. So now we are turning into Honey Boo Boo. Well, my conclusion here is AngularJS still provides a lot of attack surface. And the framework is so complex that we really need to be watching closely what is happening. And we need to be systematic about analyzing the security properties. In many situations, when you audit a website that is using AngularJS, it is getting extremely hard and tedious. It's really hard to find vulnerabilities. You know that they might be there, but you can never clearly pinpoint them unless you really know AngularJS. This is the same for developers who want to build websites using AngularJS. They not only have to understand the framework, they also have to understand the shortcomings of that framework and the shortcomings that appear if you don't follow the philosophy of that framework. And complex websites are complex, so there's always ways that you want to utilize that cannot follow the standard. And when you see those join points, these kind of complicated areas in a website, for example, interaction between two domains, and AngularJS being in place, then you can almost be certain that you have a bypass, that you have an attack. But to be able to carry out that attack, you need to know the sandbox bypass or find one on your own. And that's the complicated part. One of the topics of future work for us is to create a sandbox bypass guide. That means we're currently building a tool that gives you all known sandbox bypasses sorted by version number. So whenever you run into a penetration test against an AngularJS-driven application, you just have to use the tool and enter the version number and get the proper bypass. It's not done yet. I hope it will be done within the next 2 weeks. But I guess this is one of the few ways that we can actually ease penetration testing websites that use AngularJS. We also can conclude that using old versions of AngularJS is very, very dangerous because the old versions have many bugs. And even if you have an injection into a website that uses a very new version, you can bring the old version back. And we also learned that an open source project for a library that is used everywhere, that has a lot of traction and thousands of commits, is dangerous because people might oversee security issues even if they are maliciously introduced by someone from the outside world. However, to be positive, Google's security team already does well, and they do a lot to make AngularJS even more secure. I do believe, however, that there is room for optimization and that Google could do better in helping developers because there is not so many guidelines out there that teach developers how to securely use AngularJS, and that is still missing. Maybe this is also one of the outcomes of this presentation. We'll see. That is basically it. We have seen 4 different attack patterns: attacking the sandbox, attacking the sanitizer, attacking the CSP mode, and last but not least, attacking the code base. And all of the 4 attacks were successful. So let's see where this goes. And I'm very excited for future versions of AngularJS, and especially excited for version 2.0, because then again, everything will change. And the web will change along, And so do we as penetration testers, because we still have to be able to evaluate and assess security of those websites. And we can only do that if we really know the browser, if we really know the framework, and if we really know the application. And that doesn't make it easier. Last but not least, credits go to Gareth McHayes, to Jan Horn. Actually, he's called Gareth Hayes. I just say Gareth McHayes because I want to tease him. To Matthias Karlsson, Gabor Molnar, David Ross of Google, and Eduardo Vela of Google. And those two gentlemen, David Ross and Eduardo Vela, actually permitted us to do this attack against the code base. So thanks to them. And thanks a lot. And also thanks a lot to you for attending this talk. And if you do have any questions, then I think now is the time.
今日は有意義なプレゼンテーションどうもありがとうございました。ちょっと私 JavaScript 周り細かいところあんま詳しくないんですけども、基本的にその JavaScript とか使ってる時点で脆弱じゃなんかっていうふうに言うような、姿勢、普段からそういうふうに思ってまして、こういう JavaScript 系の脆弱性を普段から診断してる方の立場として、やっぱ絶対に脆弱性なくならないんだから JavaScript なんか使わない方がいいんじゃないかみたいな意見に対してなんかコメントがありましたらちょっといただければと思ってます。
Yes. I believe that JavaScript itself is not vulnerable or attackable. I believe that JavaScript in combination with the DOM creates the vulnerabilities. Because the DOM is the one that is turning strings into code. Inner HTML, function constructor, HTML elements, etc., etc. So I would still recommend to develop JavaScript and JavaScript applications of all kinds. No problem with JavaScript at all. But the problem I have is when JavaScript hits something else, like the DOM or any similar layer, then vulnerabilities appear. Because new language features and unknown language features of JavaScript don't necessarily transpire to the DOM in a way it's safe. And that is the majority of vulnerabilities that we find in applications. Not vulnerabilities in JavaScript itself, but vulnerabilities in JavaScript plus the DOM.
ありがとうございました。
AngularJS 以外のフレームワークは興味ありますか？例えば今日本ではとても ReactJS が人気なんですけれども、 ReactJS はとても上手に DOM を隠蔽していると思うんですが、それについて何かコメントありますか？
Yes. I think React.js mostly takes care of the view and not of the controller and not of the model. Actually, we tested React.js very thoroughly, and we thought it was fine. So vulnerabilities in React.js are hard to trigger, and they are rarely caused by the framework itself. Whereas with AngularJS, it's clear that the framework causes the vulnerabilities because the framework exposes new features that can be abused. We also had a look at other frameworks, Ember, Knockout, and similar. But AngularJS was still sticking out in terms of numbers of bugs, numbers of new patterns, not always the best developer reaction, never any CVEs despite security vulnerabilities. So I think other frameworks have problems as well, but AngularJS deserves the most attention because popularity and number of issues and development processes.
Thank you.
Thank you.
質問なんですけども、CDN を使った CSP のバイパスに関してサブリソースインテグリティ SRI が防御の手助けになるかと私は思ってるんですけども、それをバイパスする手法みたいなのは何かご存知ですか？
Yes.
はい
Sub-resource integrity is no valid fix because you would just fetch a valid resource and you as the attacker would just provide the hash and that's it. So you don't have a compromised CDN, you just fetch something else from the CDN. You just calculate the hash and you're done. So SRI is not a solution.
ありがとうございます。
Thank you.
それではファーストセッション
Okay, so I think the end of the session, the timing has come, so we would like to close the first session. Thank you very much, Maria, for your wonderful presentation. Let me join.